Hi, in this video I'm going to present the Glasgow Network Function Virtualization Framework. We maintain a website at glanf.dcs.gla.ac.uk where you can find more information about the project and help for deployment. There is also a link to our Docker and GitHub repositories where you can find network functions and source code of these network functions. First of all, I'm going to show you our HTTP filter. Here in this screen you can see the GLANF user interface with 3 servers in it. 192.168.0.1 is used as a source for the traffic, while 192.168.0.2 is used as a destination. In the middle you can see our GLANF server that runs all the network functions, and it has an IP of 192.168.0.3. To start a network function, the user needs to specify the image of the network function and the host that the network function should be attached to. Attaching a network function to a host means that all incoming and outgoing traffic for that host will go through the particular network function. In this particular example, we will see that our HTTP filter drops all HTTP packets that contain the string hack in their post header. Before even starting the routing through the network function, we can see that both requests, one containing simple data and another containing the string hack, succeed. After starting the routing through an HTTP filter, we notice that the request without the hack string succeeds, while the request with the hack string fails. Apart from filtering the requests, this HTTP filter also sends notifications to the user that can be seen in the GLANF user interface. The next example is a firewall. Here I have already started a container for the firewall. As you see in the inspect menu that it's running, but it's currently disabled. That means if I ping from the client, the ping succeeds. When the routing has started through the network function, all ICMP requests are dropped. The next example is a rate limiter. As you see, I've already started a network function with the GLANF/rate limiter image. I put a large file to the server that we are going to download from the client. When we start downloading it, you see that the initial bandwidth is 31 megabyte per sec. After starting the routing through the network function, the bandwidth is throttled down to 14 megabyte per sec. After disabling the routing through the rate limiter, we see the recovery of the speed. In the next example, we are going to use Snort, a popular intrusion detection and prevention system. I've already started a container with the Snort image, and we set Snort to notify the user for any suspicious traffic. As the notification level is set to the highest, as you see, even an ICMP message raises a notification to the user. We have also implemented a simple DNS-based load balancer that I'm going to show you. So we have just started this network function and placed it between the client and the server. The network function inspects all DNS traffic, and as you see, it replies to the client with various IP addresses for a specific domain. In the current example, as you see, the test web page domain is resolved either to 10.0.0.1 or 10.0.0.3. Finally, I'm going to show you what's happening inside the GLANF server with the containers. If you type docker ps at the GLANF server, you can see all the running containers that all represent a network function. We can also jump inside a container, let's say the load balancer, and look around. As you see, the implementation of this load balancer is written in Python, and it uses the NFQ and the SCPy libraries. Also, if you type ifconfig, you can see that there are 2 interfaces in each container, namely IF1 and IF2, and the container is responsible for the traffic forwarding between these 2 interfaces. Thank you for your attention.